So my name is Jo Wells. I am the City of Bend's facilities architect and principal project manager. Bit of a mouthful, but really on this project, I was the city's lead. So I was the main driver from the city, working with the project team to make sure that the project was executed in the parameters given to us, and that it was really going to meet the needs of the departments. So I think, Galen, you're pulling up the rest of the presentation. While he's doing that, I will give a little add-on plug, having just learned about that event on May 14th that you presented about. May 14th is also our grand opening. So if you want to go to the ETO event and then slide over and see the Public Works campus in person, we will be doing our grand opening and art exhibition until 7 p.m. that evening. So just want to put a little plug in for that. So what is this project? So we had 5 primary departments that were really outgrowing the existing facilities they were in. Some of them previously had been co-located and had been split between campuses over time, just because City of Bend has been growing and started growing pretty exponentially the last 10-15 years. And so we were outgrowing our existing facilities. We were no longer co-located together as a Public Works group of departments. And our facilities were really aging and needed a lot of work and weren't really meeting the needs of our staff anymore. And so in 2021, the city hired me to really drive this project and bring us all together into one campus. This is just a kind of overview of some of our existing facilities. If you want to go to the next slide, and you can really see that these buildings, they were not purpose-built. They were used buildings when the City of Bend obtained them, previously used for other functions, that they were doing really good at making do the best they could, but really were not the most efficient for the kind of work that we do. So like I said, 2021, I was brought on. We went to council and asked for 35.5 acres of about 1,500 acres that the city owned on the northeast side of Bend to be allocated for this campus. Those 5 departments consist of our public works groups, engineering, fleet facilities, transportation and mobility. They maintain all of our streets, our water services, which does all of our utilities, water and sewer and stormwater for the city, including the water laboratory, and then our facilities department. So we really brought them all together. I worked on a very basic program, just understanding kind of the size and potential growth of those departments over the next 30 to 50 years, and put together a rough schedule before procuring the team. That schedule was driven by our Boyd Acres facility that had already been sold to another entity here in Bend, and we needed to vacate by the end of 2025. So that's what drove the schedule. It was the City of Bend's first vertical project in 20 years, hence why they hired me at the start of the project, because there wasn't anybody on staff that was already experienced in really driving large projects like this. And then we had some sustainability plans, which I'll get into later a little bit. But mainly we did decide before even putting the RFP on the street that we were going to enroll in the Energy Trust program in some form or fashion, after having talked with Ellen and others at Energy Trust and understanding it's really a no-brainer. There's not a risk to the owner to enroll. It really just helps get some incentives to even have the conversation and that initial kickoff, which Elena will talk about. So once we decided to make this a real project, we decided to do an alternative delivery called progressive design build. We chose this delivery method for a number of reasons. One of them being that it is a very collaborative approach. We hire our architect and our contractor as one joint team, and all the subcontractors, trade partners, and consultants fall under them. But what's really great about it is you bring everybody on when you're still super early in the planning stages. And so this team that's going to be talking with you today, many of them have been on this project since 2022 when we did the initial hire, or shortly thereafter. And so that close collaboration really made a lot of what came to be possible by having those early coordinations with contractors and trade partners that were going to eventually do the installation. So if going to the next slide, as soon as we got the project team on board, we set our project priorities, and those fell into three main categories. The first one was an efficient and innovative workplace. This is really focusing on our staff and making sure they can do the best jobs by having facilities that really support what they do and encouraging them to connect and collaborate and cross paths with one another on a regular basis. The second one was community benefits. As a public agency, that is our top priority, is that we serve our community. And that includes fiscal responsibility. And so every measure we did, every decision we made, is it fiscally responsible? Is it the best value we can have? Not necessarily always the lowest cost, but looking long-term at a 30 to 50-year facility. Does this make sense? Do we get the payback that we need to make that a good decision? And then the last one is what we're really focusing on today, which is regenerative planning and design. And that is our sustainability arm and goals of the project. Next slide. So with that, we had, as I mentioned earlier, two main plans that did exist in the city prior to this project. Neither of them were created knowing this project was going to be kicking off. And like I said, we hadn't done a vertical construction, meaning building projects of any size, since the early 2000s. So it had been about 20 years. That we did have a strategic energy management plan that really focused on how do we reduce the energy, mostly in our existing buildings, but with some kind of eye to potential future buildings as well. That became a really good guide for us. And then our community climate action plan, which was a plan that was really set within the community of Bend as a whole, not just city facilities. And that's where we said, as a community, we really want to drive to 40% energy reduction by 2030 and a 70% by 2050. And so those were two markers we could really kick off this project with. And so with that, and knowing that we were already enrolled with Energy Trust of Oregon, and those two plans mainly focused on energy and low carbon footprint. And so those became our focus. And with that, we decided to go with the Path to Net Zero program, not yet knowing if we were going to make it, but that was kind of the goal. And so Elena, how did you get us there?
I cannot take all the credit at all. But hi, everyone. I'm Elena Goldstein-Lake. I'm a technical lead here at Brightworks Sustainability. We're a sustainability consulting firm. Our headquarters is here in Portland. We have a few other offices around the U.S. We help organizations set and achieve their sustainability goals, provide services like net zero carbon road mapping, greenhouse gas accounting, energy analysis, and body carbon analysis, and also green building rating system certifications like LEED. We were really excited to join this project because not every project is like the City of Bend with real actionable climate goals that were able to serve as the backbone for all of the sustainability strategies and the sustainability story that we're telling today. So we were able to take those goals and turn them into a real project. Back in June 2022, the team participated in our Eco Charrette. The objectives of the charrette were to take the sustainability priorities that were already identified and explore them more deeply as a group, inspire the team around what's possible by sharing some preliminary analysis, precedents from other projects and frameworks, and then also to come away with a draft of the project sustainability commitments and goals. And we continued to, that draft continued to evolve throughout the rest of the project during design and construction. Prior to this workshop, the Brightworks team established 4 sustainability issues that we were going to focus on: energy and operational carbon, embodied carbon, resiliency, and health and happiness. And we set the tone by ensuring that the discussion never lost sight of those guiding principles that Joe mentioned. So the city's climate action plan, the strategic energy management plan, and also fiscal responsibility and considering how to best serve the community. The charrette participants brainstormed strategies for each of these I'm still on the last slide, but it doesn't matter. For each of these 4 sustainability topics, so the Brightworks team got this started by pre-populating these items that were already aspects of the Strategic Energy Management Plan as baseline, and then everybody added on from there with more ideas and strategies and things that worked well on other projects. We used color coding for the 4 different categories. And then after we strategized everything, we mapped it to baseline, target, and aspirational. The baseline strategies were typically either already included in the city's goals or cost neutral or just general best practices. But what was great was of the targeted strategies, we incorporated most of those into this project. So an all-electric building designed for battery storage, radiant floors in headquarters, night flushing, some passive design strategies, which we'll get more into, and a few of the aspirational strategies made it in as well, including extra PV for the future and working towards a full zero energy campus. And then next slide, just to drive home how this project was different than other projects, LEED itself was not a goal for the project, but after the team reviewed multiple sustainability frameworks, LEED, ILFI Zero Energy, Zero Carbon, well, LEED was noted as the best fit because ultimately all of these, the green highlighted credits were matching the city's project priorities. So by mapping those to the LEED scorecard, we landed at 59 points, which is just 1 point shy of LEED Gold. Again, this was more about the intent behind the strategy that led us to a LEED Gold project. So it just feels great knowing that we're about to hit submit on our LEED Gold certification for the full campus. And all of the points that we're earning are really intentional and we're not points chasing. And just a few quick notes. We started off, this is an early scorecard. We started off confident with 14 energy points. We earned all 18 energy points on this project, of course, and all 5 for renewable energy. And then a couple other strategies that I thought were worth noting that we don't see achieved on that many projects is the 3 points for rainwater management, for managing all of the stormwater on site, and also 3 points for daylight, which we'll talk more about later. And then also earning social equity in the project team for Pen of Arietes and Brightworks Just certification labels. And I will pass it over to, I'm going to pass it to Galen.
Yeah, hi everyone. My name is Galen Whalen. I'm an associate here at Pen of Arietes Architects, and we were the architects on this project. And so you've heard a fair amount about how this project came to be, some of that early goal setting, but you haven't actually seen the project. And so you can see the campus here. We're looking from the north side of campus across this 35.5 acre site. We're just the north boundary of it. You can see off in the top right there is Pilot Butte. So if you're familiar with Bend, this is part of the Juniper Ridge district, and so it's a developing area. And so of those 5 departments that were brought together, we have that basically resulted in these three buildings and a fair amount of site area laydown equipment storage space. We have the fleet maintenance facility servicing all of the city's fleet, including fire and police, and that has 6 heavy bays, 4 light bays, a whole bunch of technical stuff that we can get into. And it also is where the central utility plant is housed. It has a small office for the fleet staff to do some of their work there, and we did look at how that can expand as well. We have the operations building, which sometimes is referred to as warm vehicle storage, which is where a lot of the critical snowplows, Vector trucks or snorkel trucks, whatever you want to call them, are stored. That's a freeze protected on the west portion of that, and then also all the shop spaces. So a dedicated wood shop and metal shop, things like that, rather than spread out throughout all of City of Bend. also has a warehouse. That's a pretty critical portion. And then on the top, there is a second floor on that eastern half facing the courtyard for more storage. And then in headquarters, we have kind of the main hub of the whole place. Everyone is kind of passing through this. We have locker rooms on the ground floor, a really wonderful break space that we call the intersection. It's facing south onto that open courtyard, meeting, huddle rooms, all of that. On the top floor, on that third floor in the northeast corner, we have the water lab, which is critical. Various components of the project are critical to the infrastructure and getting the city back up and running. And so we'll talk about that throughout. And then in the yard, you can kind of see this photo is taken right at the angle of some of those solar panels, carports on the just north or south of fleet maintenance there. And then a whole bunch of material storage, a decant facility, and all of that to the south there. When we were looking through this project, I just want to highlight there's so much to go over, and we're going to try and get into some more of the technicalities. I just want to highlight a few of the overall kind of overarching themes that the team tried to approach. One was designing for resources, and so we were approaching this not as we want to lower energy or do that. It's an efficient use of water, an efficient use of material, an efficient use of carbon. And so there was a pretty heavy collaborative initial work done about saving junipers on this site. There was a lot of old growth here, working really hard to make sure that was in balance, making sure that we have a lot of earthwork on this project, and it's a cut fill, it's a negative or a neutral. And so working really hard to place those buildings within the landscape and not trying to just flatten the whole site and put buildings where we want to. We also wanted to make sure that we have these passive design strategies that set us up for the most efficient systems that we'll get into in a little bit. We also wanted to make sure we had a design for resiliency. Climate is changing, and we want to make sure that things are resilient, especially when it comes to facilities like this that are not necessarily critical to the level of a police or fire station, but that doesn't mean it can't be as resilient as possible. And so durable materials, the central utility plant and the efficiencies there. We have backup power through a generator on site, but we also have space allocation for a battery backup system in the future, and the microgrid brain is kind of already in place, which we'll get into. We also looked at expanding. Bend is still growing very quickly, and so what we have on day one versus kind of anticipating how the city might grow into the future, that was taken into account with how things are laid out, where the projects or the buildings are on the campus, and how they might expand. For fleet, we might be able to expand in the future to the east if that need was there. We also wanted to make sure that we were designing for well-being. We're going to spend a lot of time today talking mostly about energy and things like that, but it's about the people that are in this space at the end of the day. And so we want to make sure that this is a warm and welcoming, beautiful place to work. Some of these crews are in here at 4 in the morning getting ready to maintain the streets. And so we want to make sure that they have a good place to be. This is that intersection break room area on the HQ main floor. And then you'll kind of see it, the overall central courtyard preservation and the views out to nature was really important for that well-being. And so we kind of coming back to the path to net zero, that was kind of woven into every decision and helped us really reach those goals. But I just want to highlight how closely the team worked across all disciplines, but here we're really talking about the collaboration that Henbury Eddy and the contractor and consultants worked with Brightworks and ETO on how that's going to be informed by data. We're not just kind of doing these things rule of thumbs. There was a lot of iterative studies, a lot of back and forth with Brightworks and people here who's going to dive into some of the energy modeling. So I'm going to pass it off to him.
Thank you, Galen. Good afternoon, everyone. I'm Vipul Babria, and I'm the technical lead for the building energy modeling analysis at Brightworks Sustainability, where I collaborate with our other discipline, lead and living building challenge management, healthy materials, embodied carbon, energy auditing, commissioning, and decarbonization, to name a few. With over 12 years of experience in the building energy simulation and performance analysis, I specialize in developing energy models that supports high performance building, design, and data driven decision making. Today, I will be presenting the key insights of our development of net zero path and associate energy analysis of that of the City of Bend Public House campus. We will start with this energy benchmarking and what is energy benchmarking, which is very important first step that ETO requires. Since this whole campus is path to net zero ETO, going for the incentive for the path to net zero, we need to establish the benchmarking. Benchmarking is kind of building energy analysis that refers to the process of comparing the building's energy performance against like a standard or the reference point. This reference could be similar to buildings' historical performance or established energy efficiency targets. The goal of benchmarking is to understand how efficiently a building is using the energy. So, for example, we often use the metrics like the energy use intensity, which calls the EUI. We often see that in the Energy Star portfolio manager, you see the energy use intensity, which is the measures the energy consumption per square feet per year. Next, please. So how we establish the benchmarking for the City of Bend campus? The campus is with the 3 different buildings, and then the very first thing that we need to establish the requirement of the path to net zero, which is like 80% of the reduction from the benchmarking UI, whole building energy use intensity. There are 3 buildings here for the headquarters, fleet maintenance, and the farm vehicle storage buildings. Our team was involved from the concept phase, very early stage. This is the one project that we were really early on the design. So, and those 3 buildings are kind of the unique with the space programming requirement. We really work very closely with the ETO engineering team to establish a path to net zero target. We really appreciate the ETO's team for providing their valuable feedback during the entire benchmarking analysis. During the analysis, what we have, this is not a typical building, so we have to go through like a couple of source, like a benchmarking source data, including CBEX and lab benchmarking tool. And we've also established the kind of the accounting for the existing equipment that going to be in these new buildings. So we review the existing equipment usage and we customize the energy use for process and plug load and establish the whole building EUI for each building. So on that development of our energy use intensity for the first building was energy, the headquarter buildings. These headquarter buildings typically has most of the office spaces, and then there is a water laboratory space as well. So in order to develop this whole building UI, we went through the equipment, also the equipment going to be installed in the water laboratory, and we established the whole building UI based on the area weighted average method for the office space, like a total square footage of the office and the lab spaces. Once we establish the EUI, we have a path to net zero target, which is 80% of the whole building EUI. So we come up with that path to net zero target for the headquarter building. Next, we go for this is the one vehicle storage building, which is operation building, as Galen mentioned before. This building is also a majority two types of spaces, which is a warm vehicle storage, which is kind of the semi-heated space, and then the maintenance shops, which has both heating and cooling. So the whole building UI was established based on the square footage and our analysis of the equipment to be installed on the shop in the shops area. Similar to headquarters, we follow the same methodology, and we collaborate with the ETUS engineering team to have the establish the path to net zero goal. Next is for the fleet maintenance facility. We have followed the same similar procedure. However, the fleet maintenance facility has only shops in a space type. So we established the whole building EUI based on the CBEX, and we have a target of 80% of that EUI reduction for the path to net zero. So once we establish this all path to net zero targets, so our approach was like to reduce the internal load first, which is like kind of specifying the high performance interior lighting, and then we investigate on various passive reduction strategy for each building and envelope enhancement strategies. This would reduce. So first we focus on reducing the heating and cooling demand of each facility. Then we analyze the high performance heating and cooling system with specifying the heat recovery on a air handling unit, so the heat can be recovered from the exhaust. So this whole campus was served by the central utility plant, where we have an air source heat pump provide the heating, hot water and chilled water to each of the facility. Once we have, when we reuse the energy, and then the remaining portion will be offset by the renewable energy, which in this case that we are targeting to offset 100% of the campus energy use. The next slide, please. So we begin the analysis very early stage, and we really recommend the project team to start the energy modeling very early in the design, and this is what we did with this whole project. This really helped the project to establish the target at the very early stage, and also to narrow down the design options. So here we can see the different columns where we started modeling energy model for the building, which this for the headquarters. We started with Oregon Energy Code whole building and a whole building EUI as a baseline, and then once we developed that, we developed the proposed design case model, which is the second column, 40.1 kBTU per square feet. We have a multiple iteration of the to analyze the energy efficiency measures. But every stage of the design phase, like in a schematic design, we run the multiple iterations, and even design development and also the construction document phase. We meet with a design team to brainstorm energy efficiency measures. This is really a collaborative effort. Based on their feedback, we run the multiple simulations to provide them feedback to the design team and also help inform design team on the design option to meet the path to net zero target. We have a different, and then there are other two columns. We recommend the energy efficiency measures, and then finally we can reduce the energy as much as we could based on the requirement. And then the remaining portion, where you can see the 15 kBTU per square feet, will come from the renewable energy on the campus. Our target for this part of headquarters was 22.5 kBTU per square feet. Additionally, we also analyzed this energy efficiency measures for the headquarters during the design, mainly because of this. The headquarters has full energy heating and cooling. We focus on the demand control, ventilation, reduce supply air, and the energy efficient lighting, and some glazing measures as well. The chart indicates that each measures reduction of the energy use in kBTU per square feet, and we also analyze if all these energy efficiency measures included in the project design, it will reduce 2.5 kBTU per square feet of energy. Similarly, we all established the baseline for the operations building, which is a warm vehicle storage. We went through the multiple iteration during the design phase, and in the proposed design, we established the proposed design energy use intensity was like 8 kBTU per square feet, which actually we meet the proposed, based on that proposed design, we meet the path to net zero target, which our target was 9.3 for the warm vehicle storage. Even though the proposed design model results indicate the lower EUI compared to path to net zero, however, the design team went above and beyond, and we evaluated additional EEM and incorporated in design as well. Some of the EEMs that we have evaluated for this building is warm vehicle storage, which is the evaporative cooling with the energy recovery bills, and we also evaluated the improved wall insulation as well. Next, please. The next one is the fleet maintenance building, where we established the Oregon core baseline in the orange, 36.4 kBT per square feet. After the design iteration, proposed design, we were ending up with a 13 during the design 13 kBT per square feet, and additional EEMs that we have evaluated, we still have around like a 12 kBTU per square feet, which is kind of 2 kBTU per square feet more than the path to net zero target, which will come from the solar allocation for solar PV allocation for this building. One thing that we also evaluated very early in design was a glazing and skylight. You will see the lot of skylights on this building, which really help. We performed the life cycle cost analysis, which help influence the selection of glazing and skylights. These are some of the energy efficiency measures that we have evaluated. Mainly was the air handling unit. We have a big air handling unit with the evaporative cooling, which is with the ERV, which reduce a lot, and also the other improve the wall insulation. So basically, the design team have incorporated so many the other measures, and we have evaluated and incorporated those measures already, and then we go above and beyond from those measures with this additional energy efficiency measures. This is the path to net zero solar PV allocation charts. So basically, what it means is solar array columns indicates the total 600 kW DC solar system annual production. The 600 kW DC system was planned as per part of the city's green building technology requirement for this project at the beginning of the project. The ETO requires, so the ETO has a special requirement since this is the campus approach we are doing for the energy analysis. So ETO requires the allocation of whatever the total solar PV energy production to each building based on their cooling and heating demand. So since headquarter building heating cooling demand accounts for almost like a 67% of the entire campus, we have to allocate that 67% to the headquarter building only, and which we did for this project, which is 15 kBT per square feet based on the 600 kW total PV systems to meet the net zero target. Warm vehicle storage, we are already meeting the path to net zero target without allocating any solar PV. We have some portion, like a 9% of the PV production was allocated to the fleet maintenance building, which is kind of 2 kBtu per square feet source on the final design. And finally, we are left with about like 5.7 kBtu per square feet of the energy, which is like a surplus energy that will be used for the net to zero energy target. This building, after we offsetting everything with the design of the each 3 building, here we have 2 chart indicate the solar allocation requirement to meet the ETO's path to net zero target, which is versus net zero energy campus. The actual ETO adjusted requirement column indicates required solar PV size in kWdc for each building to meet ETO's path to net zero target. And the other column on the right, which indicates the total PV size needed to achieve the net zero energy campus for each building. So additionally, we have the project has added additional PV capacity from 20% higher than 600 kW DC. I think Joe will explain more in the later in the slides. To pursue living building zero energy certificate. This will help offset also the increase in energy use due to the weather condition, occupant behavior, and the other factors. Yeah. I will hand over to Galen.
Yeah, thanks, people. I think we're going to go right over into the systems with Greg, who is Greg Langdon from Systems West Engineers, and he's going to take it away and dive into some of these decisions.
Okay, again, Greg Langdon, Systems West Engineers, and I was principal mechanical engineer for the project. Next slide. So this is a diagram showing the campus. We have 3 buildings, and to facilitate the goals of the project, it became obvious to us that we needed to centralize our heating and cooling and electric utilities. This diagram shows a blue dot where the outdoor central utility yard is at, and a portion of the central plant is also located in Fleet. And from the Fleet building, you see the buried utilities, heating water, chilled water, they're going out to the buildings. Next slide. So here is a diagram showing the outdoor equipment yard. We can see 2 heat pump chillers with fans. Then just below it, we have an electrical generator. We have a fuel oil storage tank for the generator and some emergency boilers. And then on the left, we have our electrical equipment. In the center, you'll see that there's also an allocation for battery storage in the future. Next slide. Okay, so to meet the project goals, we established our primary heating source as heat pump chillers, and this allowed us to electrify the energy source and to improve our efficiency considerably. If you go around this diagram kind of clockwise, you'll see the blue is the heating loads in the various buildings. Then we come to the heat pump chillers. The heat pump chillers operate as the primary heating source. They do have some limitations. As outside air temperature gets cooler, their capacity goes down, and at about 5 degrees, they actually turn off. So if we are unable to maintain that 125 degrees, we move on to the supplemental side stream arrangement here, where we have 2 900 kW electric boilers, and then we do have 1 3400 MVH natural gas boiler that is only used in emergencies. So for normal operations, this is an entirely electrified heating system. Next slide. The chilled water system is similar. We have our, the blue is our building loads, and we have our heat pump chillers. Our heat pump chillers are sized to meet the entire campus load and provide 42-degree water out to the buildings. Next slide. Okay, there were a lot of really exciting things about this project. The water lab was very interesting. The DOAS units with chill beams was another really kind of exciting part of this project. But one I want to make particular note of is the radiant heating and cooling. We extensively used radiant floor heating and cooling throughout those buildings because there were some real advantages to using that. In the headquarters building, it really helped us with the aesthetics of the building, with the mass timber, open design. We were really looking to minimize the visual appearance of any mechanical systems, and we were able to get much of the heating and cooling under the slab. Additionally, in the fleet and warm vehicle storage, we're dealing with areas with really large ventilation loads. And the radiant heating and cooling slabs allowed us to transfer energy in a radiant mode and directly onto automobile or vehicles or occupants in the fleet, and just made our heating much more efficient and allowed our operating temperatures to be lower and still provide the necessary heating to the space. So there were some, one other notable advantage is that the radiant floor heating system allows us to turn the buildings off, or the HVAC off in the building at night, the air handlers, and just heat the buildings with the floor slab so we don't have fans operating at night. Again, improves efficiency. There were a few, I'll go on to electrification. In terms of the site, the primary energy or electric source here is solar. Day one, the fleet building has solar. Many of the covered parking areas have solar. We also have solar-ready roofs on HQ and ops. Yeah, as I stated before, all of the centralized systems operate off electricity. Finally here, the backup power. To meet the resiliency requirements of this campus, to operate during adverse weather or when there's a power outage or whatever might be thrown at the campus, there are critical functions here. And so certain portions of this campus need to be operated continuously. And that required backup power. The areas that are served by backup power are the headquarters level 1, the water lab on level 3 of the headquarters, and then the fleet building in total is operated off of backup power with the central plant. The ops building may require standby power, but it was decided that it would be better to bring in a temporary generator and connect that directly if that ever came to pass. And then again, the future backup power system would also support that standby power operation when that system is added to the mixer. I think we're going on to the next person here. All right.
Going off to renewables and that 1.5% green energy technology, I'm just going to pass it off to our solar trade ally, Joe Mazzarella.
All right, thank you, everyone. My name is Joe Mazzarella. I work with Sunlight Solar, there was I think Joe Wells was going to talk a little bit about this as well, but there is a Oregon law that 1.5% of public projects is spent on green energy on site. And so they did have a budget set up for this. And when we were brought on, it was understood there was a budget and there were some goals. And so what we came on to do in the pre-design process, which I highly recommend anyone working with these projects does, set up some time and bring on a solar contractor fairly early to work with the design team, the ownership, and Kirby Nagelhout, the construction team, did a really good job of organizing all that and keeping everybody kind of on task and everybody in communications with each other. So we worked for probably a good portion of 6 months on this design, going through some value engineering options, worked with the energy modeling team that we've already heard from, and trying to find out what that target number is. And so we had a number to, as far as for solar production to target. We also had to work closely with Pacific Power. They have, for a system of this size, they do need to do some level 3 engineering studies to make sure that the lines can handle the amount of backup power, as well as the you know, the substations and whatnot. So that does take a bit. You want to set aside some time for that. And also obviously with the structural engineers, the electrical engineering team, the electrical contractor, everybody's got to be on the same page. And so the kind of the scopes can be delegated of who's handling what. We knew that the goals were net zero. They did want to start off with a fleet. That roof was ready and close to the central utility plant that Greg was talking about. And they also wanted to look in some kind of dual purpose carports. By dual purpose, what we mean is that they act as actual carports, shading the vehicles and everything from the weather, as well as producing power. You see a lot of these down in California, Arizona, very sunny places, to shade cars and parking lots everywhere, and we're starting to see them a lot more up here as well. Also during this value engineering design process, the shade canopy, which is kind of a city employee kind of lunch area or whatever, as well as a bike canopy, which if people are commuting via bike can park their bikes in. Both of those also have solar panels on them. Again, a kind of a dual purpose solution there. And then we knew we had kind of in the back pocket the operations building, and the city made it clear they'd rather use that later as a, you know, or only if we needed it, but really kind of the idea was use it later if we needed more solar as the city expanded and grew, and you know, their usage on the campus was more than originally thought due to growth and whatnot. And so what we did is we worked with the team and presented some options and budgets, and what we came up with was basically we came up with the shade canopy and bike canopy, both nearly 20 kilowatts each. You can get a vision of one right there. I believe that's the shade canopy. Then the fleet building, we got about 240 kilowatts up there. The shade and bike canopies are connected to the inverter system in the fleet canopy. That seemed to be the best way to do this through the design process, as well as 4 carports, each just over 100 kilowatts each, and those all interconnect in the same spot at the central utility plant, and that's where they also they connect with the microgrid controls as well. So the energy production, if you look on the right, this is kind of what the different system sizes, what each of them should kind of produce. We ended up with 708 kilowatt total. This is a little larger than what we think will be needed for net zero, depending on the energy modeling, but this does give some buffer and also can help with future expansion of the campus. So definitely looking forward on that on the city's part. And you know, there you see the net zero estimate, about 840,000 kilowatt hours. We should be coming in around 1 million kilowatt hours. So we do have that buffer there, which will also help with their net zero certifications, their living building programs and such. This also comes with monitoring. The SolarEdge website monitoring does provide alerts if something goes down. Does give real-time and historical production. On the previous page, you saw it did have the panel level, inverter level monitoring, where you can actually see each panel and make sure that it's operating as expected. And if one is out or 2 are out, you would know each of these panels has optimizers on them. And that allows you to really kind of get a granular vision of what this system is doing, and if anything goes down. On the bottom portion of this, you see the inverter level, and they all kind of have the same bell curve. This is from about a month ago, month and a half. It was a snowy day, so it was there was kind of a lot of action in the bar graph there. And on a nice sunny day, it'll look like just a bell curve. And so another thing about the SolarEdge monitor, it's nice, it does have the public view option. The city chooses to kind of ever put in like an educational kiosk or have a link on the website to show what the solar is doing. They can do that as well. That big building on the left there, that's the operations building. That's what the city kind of has in their back pocket for future expansion. Very nice kind of slightly west-facing array. So we do know that that is ready. It does have the collateral load for solar.
Thanks, Joe. Yeah, so just briefly, I'm going to go pretty quickly here so we still have some time for questions, but wanted to highlight some of the passive design and the health and well-being strategies that were incorporated at an early stage. We have, as you've heard, some very efficient systems and the renewables that are necessary to bring this project to net zero, but there's a lot of early stage massing and facade articulation that we want to do so that those systems don't need to be as big as they are. And so that was some of the early stages, and it was also a form driver for a lot of these buildings. On HQ, we could really dive into the daylighting and the passive shading strategy. These kind of thickened walls that you see were informed by probably hundreds of glare and daylight studies. They're slightly different on each facade, and they relate to the width of the openings as well and what's going on in the program inside. And so the interior daylighting, as Lena mentioned, we got the 3 points from LEED for daylight. The HQ building is just over, I think, 75% for that metric, spatial daylight autonomy, and some minimal glare. So from a user standpoint, it's really nice on this, east of the Cascades. It's a lot sunnier and get these beautiful expansive views out onto the courtyard and to the Cascades, but it also lowers the need for our electric lighting throughout. On operations, Vipul mentioned that we did some studies on the building life cycle cost for both the skylights, as well as we looked at triple pane glazing on HQ, and it's those little studies that I think were really helpful and informed design decisions along the way. And so there's a lower foot candle requirement in the operations building, and these skylights, along with the translucent north and south expanses, are really bringing the amount of daylight that's needed in these spaces without any kind of electric backup. So it's just one more thing that doesn't have to be on the generator or hooked up to that battery system. In Fleet, we have large expanses of that translucent material on the north and south, as well as clear overhead doors for safety. This space is, you can see, if you zoom in there, it's about 91% on the spatial daylight autonomy. So really, the lights do not need to be on in this space, but we also want to make sure that we have a sizable overhang on the south so that we're blocking that summer sun. And we have one on the north as well, specifically hoping to avoid ice damming and all of that as cars are leaving in a north to south circulation path through here. I mentioned briefly the access to nature and the sensitive touch that we tried with this this project. It's a huge campus. Of course, there's a lot of laydown material and things that needed to happen, but the team was really committed to, we don't want to just level this site and put things anywhere. We really wanted to selectively place these buildings and the program components of the site threaded throughout it. And so we can see here where these green chairs are in the main image is a rocky outcropping. And so as people are checking into HQ and then going off up to their workstations on the second and third floor, or off to Fleet or operations, their walking paths are through these old junipers and these walking paths and rocky outcroppings and places to grab lunch and things like that, to secure bike parking. And it was really important that that courtyard space of preserved junipers was not just for the office workers. We also made sure that in operations, the shop spaces, which you can see in the lower right, those are facing out onto the courtyard as well. And so spaces that typically don't necessarily have the best views or get prioritized for views, we wanted to make sure that the people that were in those spaces working every day also had access to that. And then on the third floor of HQ, we have this third floor terrace, expansive views of all of the Cascades. And it's also a public space. So public can come up there. The largest conference room on the project is on the third floor and has capacity for public meetings and such. On the inside, Greg mentioned we worked really hard to expose the CLT structure. We also have mass plywood in warm vehicle and Fleet, and throughout making sure that we have exposed wood, plants, a pretty special stair in the HQ building that is very open, very social. People are using it having informal conversations and such. And now I'm going to pass it off to Joe to talk about some of the incentives.
Yeah, so like I said at the very beginning, we approached this really with a best value mindset from a financial standpoint. So all of these measures that you're hearing about today, or that you have heard about today, are all tied into that analysis that we continuously did throughout the project, looking not just at first cost, but also long-term cost. And so this slide just shows some of the incentives and grants that we were able to procure as part of the project for energy and sustainability measures specifically. We brought in about $600,000 that can be applied or went right back into our budget to allow us to really maximize budget utilization. And then we expect about $400,000 of the direct pay program. And for the remainder of the life of those solar panels, at least, we expect to be saving about $100,000 per year of those energy savings in what we get back from our energy provider. Elena, do you want to tell us a little more detail about ETO incentives specifically?
Yeah, just to wrap us up here, I think since I managed the ETO incentive process for Brightworks, Ellen asked us to share a few quick tips and tricks and lessons learned with assisting in that coordination and the backup documentation. So first, just familiarize yourself with the website. There's a lot of information on there. There's a lot of different incentive programs and opportunities. So keep the notes handy from your design assistance meeting and ask questions during that meeting as well. Lean on your ETO contact. Ellen is so lovely to work with and really supportive of us when we had any questions. So we remained responsive and engaged, and so did she. And that's been my experience working with all the ETO team members. And also understand the documentation required and who you're going to gather it from. So, for example, is this going to come from the general contractor? Is this going to come from a subcontractor? Looking at like metering, for example, we're looking at, there was some confusion. Does this come from the solar contractor? Or does this come from the electrical contractor? So working with the team to get those questions answered to find out what you need and who you need to get it from can really help you dial that in to have it go much more smoothly. If you have access to submittals yourself that you could just pull and give to the ATO team, and just really understanding, who is responsible for what on the project can help you get the backup documentation that you need. Those are just a few tips